This video is going to cover section 4.5, finding the equation of a sine or a cosine graph. And the target is that you should be able to write an equation of a sine or a cosine wave when you're given the graph or when you're given the maps, or the middle, amplitude, period, and shift. So just recall that the standard form of a sine or a cosine equation is d plus or minus a sine or cosine of b times x plus or minus c. And then recall each part. D is our vertical shift, or also known as the middle of the graph. A is the vertical stretch, or the amplitude of the graph. B is the horizontal stretch, and this is used to determine the period of the graph. And then C is the phase shift, which is also known as the horizontal shift. So when we're given a sine wave, we are going to follow the same steps that we used in graphing a sine wave. The only thing is we will have a couple steps in there that don't necessarily follow maps. So the first thing we want to find is the middle of the graph. And you can either eyeball it, just looking at the graph, determine what the middle is. I can see that the max is at 3 and the minimum is at -3, so I know the middle is 0. But if you want to use an algebraic method, it's the average. So you add the max and the min and then divide by 2. So in this case, 3 plus a -3 is 0, divided by 2 is 0. The second step is determine the amplitude. The amplitude, remember, is half the full vertical distance from max to min. So it's the distance from max to middle, or minimum to middle. And then the algebraic way of finding it would be max minus min divided by 2. And in this case, we would do 3 minus a -3, which is 6. 6 divided by 2 is 3. You could also do maximum minus the middle, so 3 minus 0 is just 3. The third step is to determine the period. And so recall that the period is the time it takes for the graph to start repeating itself. And so I'd like you guys to count from maximum to maximum, or minimum to minimum. So I'm looking at this graph and I see a minimum at -3.14, and then I see a maximum at 9.42. Now each increment here that I have labeled is a distance of pi. So if I start at -pi, I'm going to count by pi's going to the right. 1 pi, 2 pi, 3 pi, 4 pi. So the period of this graph is 4 pi. Now we're not going to go to the phase shift. There's one more thing that we need to do. Because we're writing the equation, the period is actually not given in the equation. If you recall, B is the part that's in the equation that represents the horizontal shift, or sorry, horizontal stretch. And recall from graphing, when we needed to calculate the period, we did 2 pi divided by B. Now, because we're going the other way, we need the b. We just switch the period and b in our equation, and we get 2 pi divided by the period. And so in this case, 2 pi divided by 4 pi is 1/2. So we have a horizontal stretch of 1/2. And then the last step is determining your phase shift. Now, this is all going to depend on what you pick as your starting point in your graph. This sinusoidal wave has an infinite number of equations that could represent it, so it all depends on where you want to start from. So as I've said, the middle was 0, amplitude was 3, and the horizontal stretch was 1/2, or the b was 1/2. Now these three things are not going to change in the equations that we write that represent this graph. So what I did was I picked 4 spots. I have them just different colors. These are going to represent my starting points. So let's do the first one that's on the y-axis. So I have not shifted left or right, so I'm not going to have a phase shift in my equation. So I'm going to insert these 3 values into the standard form of equation of a sine wave. And since I am starting in the middle, and I don't mean the middle by the y-axis, I mean the middle vertically. So I'm on y equals 0. This is going to be a sine equation because I'm starting in the middle. So notice that this red dot starts at the maximum. That's going to be a cosine graph. Anytime you start on the middle, it's going to be a sine. If you start on the maximum, it's a positive cosine. If you start on the minimum, it's a negative cosine. So this black dot is going to be the equation, y equals 3 sine of 1/2 x. Now, you don't have to add plus or minus 0 at the end of it because the middle is 0. It's a positive sine function because it's going up to the right. It's positive to the right, so this is a positive equation. This blue dot here is also going to be a sine equation. The only difference is now it's going to be a negative because it's going down to the right. And then another difference is that I am no longer on the y-axis. I have a phase shift of 2 pi to the right. So my equation is going to be -3 sine of 1/2 parentheses x minus 2 pi. So remember, when you shift to the right, it's at x minus. Let's go to this red dot. It's a cosine, and it's going to be a positive. And then I have a phase shift of pi to the right. So my equation is 3 cosine of 1/2 x minus pi. And then this final dot, this orange dot that I have on the minimum, it's going to be the same as this cosine. The only thing is my amplitude, sorry, not the amplitude, but the function is going to be negative because I start at the minimum. And then because I went to the left, my phase shift is x plus pi. So what I'd like you to do is try this next example all on your own, and then I'm going to show you what I got. So then you can just come back to the video and check out your answers. So we're going to follow maps. Okay, so remember, do the middle first. In this case, the middle is at 0. Amplitude is at 2. The period is, if you were to count from minimum to minimum, it looks like it's going from 0 to 3.14, which is pi. This is used to calculate b. 2 pi divided by pi is 2. That is our horizontal stretch. And then our phase shift all depends on our starting points. So the points that I picked, oops, I got an equation up there already. These were the 4 points that I picked. Now you could have also picked this equation, this point up here. It really doesn't matter. So the equations that I have for the 4 spots that I picked, if I can find them all, is represented here. So take a look, check your work, come in with questions tomorrow. I'd like you guys to try example 2 completely on your own. I don't have the answers on the video, so come in with what you think your answers are for the equations. I would like you to find 2 sine equations and 2 cosine equations for this graph. And then lastly, if you are given, just the maps of a sine or a cosine function, you should be able to just write it from the given information. So I'm going to do example 3, and then I'd like you to do example 4 on your own, and then come in with what you think example 4's answer is to class, and I will check your work for you. So for example 3, it says write a cosine function that starts at the maximum. So I'm going to go ahead and highlight at the maximum, because that's telling me that it's going to be a cosine function, and when it starts at the maximum, it means it's going to be a positive cosine function. The next thing I'm going to highlight is the middle is at 2, the amplitude is at 3, and then I have a phase shift of pi, and that's to the right. So in this case, I'm going to have a positive cosine. My middle is at 2, so that means it's going to be a plus 2. Amplitude is at 3, and a phase shift of pi to the right. Now, one thing I didn't talk about was the period of the graph, and I also didn't talk about the horizontal stretch. So when I don't tell you what the period is, it's assumed to be 2 pi, which is what the unit circle is. So my answer for example 3 is y equals 2, the middle, plus 3, the amplitude, cosine, that's a positive cosine because it starts at the maximum, and a phase shift of pi to the right, x minus pi. So try 4 on your own and bring in your answer tomorrow and have me check it. So this video covered part of section 4.5, writing equations from sine and cosine waves.